In today's video, we're going to learn how to apply this 36 phase Hall sensor wire combinations, just to find one specific combination that will make a motor run. For that, we're going to use this new controller I just got, and we're going to see if it works. This video might take about it will be divided by 6 to 5 sessions because it's a long process. And I haven't seen anybody on social media do this. They generally explain what to do and give you this sheet here with the combinations, but they never applied it. So if you stick around, we'll go step by step, showing you how to do it, what works and what doesn't. Now for this controller, as usual with the other typical controllers, we have the typical cables that we need to make this motor run. Then we're gonna go quickly to the process here. All right, we got the phases here, which is blue, green, and yellow. Then we have the power cables. Then we have the learning cable as well. We have others like the throttle, the 3-speed switch, and the Hall sensors. Now, in the previous video, I mentioned that some of these controllers come with the LCD hookup, and some don't, like this LCD here. Now, in this case, this one doesn't have the plug for the LCD screen, so we won't be able to use it. I also explained in the previous video that when it doesn't have that LCD screen hookup, then we have a single cable, red one like this, and this is the one that turns the controller on. And all you have to do is connect it to the main power lead right here, and your controller will be on. But then how do you know that the controller is on? Well, if you come here to the throttle or the speed switch, all you have to do is test the voltage. It's generally from 0 to 5 volts. And this is a good idea because a lot of these cables, controllers versus the throttle, the color of the wires do not match. So you want to make sure those match, because some of these come white on the throttle as well, or blue. Okay, this is the throttle right here. Now, what generally comes the same is the green wire, which is the signal wire, which in reality is a variation from 0 to 5 volts. And depending on what type of voltage is at the time through your throttle, that's how determine the speed of the motor. And this, what I mean is, if it's at 1 volt, then it'll be a certain speed. 2 volts, the motor will be a certain speed, and so on. So you have to make sure which are your main cables here. Black and red are usually main cables. Red positive, black negative. Sometimes it's backwards. So when you test it, you'll be able to tell, and therefore you can plug in your throttle cables accordingly. In this case, my throttle cables are the same color, so I'm thinking it'll match. Okay, so I'll be back. Stay tuned, and I'm gonna connect the wires together, set it up, and I will continue so. All right, so I am back, and I have all set up for you. And let me go through the space here and show you what I got. I have the e-bike controller already connected to the terminal block. I got the phases connected. I have the Hall sensor connected. I have the speed switch, and this is important because if you don't do that, then the controller goes to full power, full speed. So you want to limit the speed, connecting the switch to at least first speed. That way you minimize the speed, right? You don't want too many amps on the motor when you're testing. And then I have the throttle here, which is this one right here. I'm using this one this time. Right, I also have my 48 volt system here. And I have my meter, And of course my motor will be using this one right here. Now, if you notice I already connected the cables, that's because I found various combinations that make this motor run with this e-bike controller. The last one I found is here. And we'll go through the process of that, explaining, you know, that whole thing. And once you find a combination, that might not always work all the time if you disrupt it, okay? So, but for now, what I'm gonna do is I'm gonna start this way with it connected with the right combination, so that way I wanna get you used to the sound of the motors and the particular things you'll be looking for when you're applying those 36 combinations just to find a specific one that makes the motor run. So what we're gonna do here is we're gonna power the motor. Okay, I'm gonna turn the meter on here, set it up. 20 amps, let's see. Okay, and what we're gonna do is we're gonna give it a little throttle. Okay, and I need you to observe the rotation of the motor. I need to power the system first. Okay, we're on. Let's go ahead and do it. See that? Okay, so the first hint here is how smooth the motor takes off with just a little bit of throttle. Nice and smooth. See that? Doesn't hesitate. Okay, so then if you give it full power or more or less more throttle, right? I won't give it too much because my camera shakes here because it's attached to the table and the motor vibrates. So okay, so listening how nice and smooth the sound of the motor is, right? From takeoff to, you know, full or half throttle. So that's what we should be looking for. Start up, nice, smooth start, and continue on, right? And then we're gonna have the amps here. If you check out the amps on the meter, it should be between 1.5 and 2 amps, sometimes 3 amps for other motors. Let's see what this one does. Let's check this out. See, that's 1.5, 1.6. Let me adjust the camera here a little bit so that way you can see more. So check this out again. Check the amperage. That's a full throttle. As you saw, 1.6 amps, 1.7 the max. That's what we need to get as far as amperage when we're testing under no load, and that's very important because if you go more than 2 amps, like 10 amps, 15 amps, maybe here I'll show you when we're testing, then that's not the right way to start, because if you leave it like that, and when whatever vehicle you build, and then you're gonna put some load on that vehicle, say yourself, with the weight of 180 pounds, 70, 50, whatever that is, and if you're gonna start off at 10 amps, when that motor is trying to move that load of 150 pounds, it's going to require more amperage. So if you start from 10, 15 amps with no load, you add the new load of 150 pounds, you're gonna be jumping up to 45 amps, 50, 60 amps. Okay, so what that's gonna do is that's gonna blow up your motor or perhaps your controller, because you won't be able to handle it. So that's why that's important under no load, keeping their amperage around 2 to 3 amps depending on motor. These small motors do, most of them do 2 amps. The large one do about up to 3 amps. So what we're gonna do next then is going to try to find, if you notice the rotation of this motor is forward, see that? Actually counterclockwise. So we're gonna try to find the reverse motion, the clockwise motions, right? And the instructions that we're gonna use to do that is this combinations for the phases and the Hall sensors. And this is what they instruct you to do whenever you have issues and you want to match, you want to run a motor with an e-bike controller and a motor. They'll tell you though, if you look up here, you have Hall sensor wires right here, and they go across 6 of them from left to right, right? That's what the Hall sensor wires are. And then when you come down here, you go down another 6, right? That's what the phase sensor wires are. And what's going to happen is, for every change on Hall wires, you're going to do these 6 combinations. Then you change another Hall wires over here, then you're going to do the 6 like that, and so on, until you find the right combination. Once you find that combination, that's where you stop, then you got the right specific combination for the motor. And in this case, I found it several places, right? I found it here with the faces here, right? Then I went here with the faces here, and here with the faces here. Also here and here, here and here and here. Now these two, I found the forward and the reverse right there with this Hall sensor combination. But right now in this particular combination, I am right here, okay? So I have it connected that way, and what I'm going to do is I'm going to proceed with what they suggest to do, which is move to the Hall sensor wires, swap them, and continue on with this phase combination. And according to the indications, that'll give me the opposite rotation. So let's start with that. It might be the case where we disrupt the process and I lose this combination right here, because that happened to me before. Maybe I did it wrong, I don't know. But we're gonna go to that and find out ourselves right now. All right.